Hello, everyone. I'm Andy from ThinkMo. Starting today, I'm going to share with you some CCNA, CCNP, CCIE related technologies. Our topic today is on switching network. How to improve link utilization. So, talking about improving link utilization, probably you think about STP, MSTP, and STP. It can also improve link utilization. We're going to talk about it today. It's not STP. Today we're going to focus on the ETH trunk. It's called Ethernet Link Aggregation. It is also known in the industry as LAG. Next we will look at three aspects. First, we need to know what is an ETH trunk. Second, what problem does ETH trunk solve? The third is how do we use the ETH trunk? So let's start with introduction. What is ETH trunk? It is mainly to connect multiple physical ports. Bind as a logical port. It can also be interpreted as bind multiple lines into one line. So the next thing. In a switching network, we're doing this for redundancy. Use the top switch and next switch. Problems with connecting multiple lines may arise. We all know it's on the switch. By default, there is one technique. It's called STP. It is called the Layer 2 Break Protocol. That's when we connect multiple lines. It creates a loop. That's when we need to break one of the lines or ports. And of course it depends on the number of connections. Under normal circumstances, line connecting two switches. Just one it works. All the others will. It was injected into the spanning tree. The original implementation of redundancy. Connect multiple wires. That's a good thing. But after connecting multiple lines, only one line can be used. It may not be easy for people to accept. At this time, then you can use an ETH trunk. Multiple ports can be added. Or multiple lines. Tie it in a line. Then someone might have something to say. This is a physical port. Bundled to become a logical port. The spanning tree isn't clogged at this point. In the process, when we put multiple ports, bind to a logical port. The STP protocol. It runs on top of the logic port. In other words, for generating numbers. It just knows you have a line. This is the ETH trunk we're talking about. Then there is the second aspect. The ETH trunk provides redundancy. It also improves link utilization. Usually we know that. If you put gigabit on a port, tie up or multiple ports, bundled together. Let's say I take between two switches. The three stops on the opposite end are tied together. So it's formed a logic circuit. So it has 3 ports in it. This is equivalent to 3 ports with 1G. They're tied together into 3G. So you can get there. The purpose of improving the link bandwidth. And at the same time, if a line has been broken, okay. The other 2 lines. Or you can keep working. In other words, redundancy. It can also increase bandwidth. It also improves link utilization. So in a fundamental sense, where is the data forwarded? It will be corresponding business data spread out over a physical line. Data forwarding is stream-based. For example, the original IP address is going to the destination. Destination IP address. It's going to stick to a line. We're not right here. Load balancing mode. Talk about it too much. So the third aspect. It can still be done. Load sharing. This is what we mentioned about ETH trunk. What problem was solved? In the process, We can use Huawei official manual. Let's take a look at this section describes the concept of F-trunk. It has 3 advantages mentioned above. Increase bandwidth. Improve reliability. Load balancing. Where you increase the bandwidth is a circuit aggregation interface. Maximum bandwidth. Each member interface can be reached. A member interface is a member interface. Physical port bundling. As an interface or a link. So the bandwidth is the sum of the bandwidths. For example, a port used to be 100 meters. Tied up at 300 m. The next one improves reliability. It's essentially redundancy. I've already said that. Traffic can be forwarded normally. This is what improves reliability. Fundamental significance. Then there is load sharing. Load sharing means that within the link aggregation group, 3 physical ports. When it's tied up, it can be on 3 lines. Share data. As to how to share, we're not going to talk about it. So there are 2 pictures here. One is that F-trunk is not configured. It only has 1 line to run. The other 2 lines don't work. If we configure the F-trunk, when one of the circuits breaks, the other 2 lines remain. You can run out. When there are no breakdowns, all 3 lines are running. And the rest of us. Let's talk about the third aspect. How to use an F-trunk interface. First, directly at the switch. Example: create an F-trunk group. Then put a physical interface. The interface is added to the F-trunk. The caveat, of course, is that do both ends. You can't just do one end. Let's say I have 3 ports. Put them in a group. The peer end has 3 ports. The 3 ports on the opposite end are also required. The interface is added to F-trunk group. And so they form each other. A logical line. Then STP is running on the line of logic. Or on a logical port. So link utilization can be solved. That's all for today. If there are any other you would like to learn, feel free to leave a comment. Or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. See you next time.